All right, here we are on to lesson 2.4. I can identify congruent figures and describe a sequence of rigid motions between two congruent figures. A rigid motion is defined as a transformation that preserves length and angle measure. So basically what it's saying is the shape is going to be the same size and same shape when you're looking at these. An example of rigid motions are translations, reflections, and rotations, the three transformations that we've been working on. In one of the future lessons coming up, we're going to talk about dilations, and that would not be a rigid motion because dilations, which will be something you'll see here in a few days, is going to change the size of the figure. But with translations, reflections, and rotations, you're left with the same shape, same size. All right, here's an example of what it's going to look like. Given the sequence of rigid motions, draw the new figure. So first of all, step one is going to be to plot figure A. So I'm going to plot 0, 0, negative 1, negative 4, negative 3, negative 4, and then negative 2, 0. And in doing this, then I'm going to rotate 90 degrees counterclockwise around the origin. So 90 degrees counterclockwise is going to be negative yx. So what I'm going to do is I'm going to take those 3 points that I just plotted. I'm going to apply the rule negative yx to go negative yx, which would be 90 degrees counterclockwise around the origin. So I'll take this first point, and this takes a little bit of time. But 0, 0, if I apply the rule, actually still becomes 0, 0. B, negative 1, negative 4 will become, it's negative yx, so I'm going to put the y first, and that becomes positive 4, and then the x second, which stays the same. The third point, which was negative 3, negative 4, the y comes first and is going to be opposite, which makes that positive 4, and then the x comes second. And then the third point, which was at negative 2, 0, the y would come first, and it's opposite y. There is no such thing as opposite 0, so 0 just is 0, and then the x stays the same. So when I'm doing this now, I'm going to plot these 4 new points, and that will consist of my rotation. So 0, 0 stays right where it's at, 4, negative 1, which would end up being B prime. This is also A prime right here. 4, negative 3. This is C prime. And then 0, negative 2. And that's D prime. Now, after I've done that, step 3 is to now translate this figure 4 units up. So I can take those same points that I just had, the ones in yellow above, and if I'm going to translate this 4 up, I'm changing the y value, and the y value is going to be adding 4 to it. So my new coordinates, by just moving it up 4, the x value is going to stay the same, and then the y value would be adding 4 to each y value. And then another way I can do that is just go over here to the graph, and I'm just going to take that A prime, B prime, C prime, D prime, and move it 4 units up. There is a double prime, that point would have been D double prime, B double prime, and then C double prime. All right. These coordinates that I just did right here in step 3 are actually the coordinates for our final answer, which would have been 0, 4, and then B would have been 4, 3, C is 4, 1, and then D is 0, 2. Yeah, so this is a problem where you're going to have to do multiple steps. What I can say about these 3 figures, if you look over at the graph, all 3 of those figures are same size, same shape. Same size, same shape would tell us that they are congruent. Okay, so when I'm looking for that, I could say that A, B, C, D is congruent to A prime, B prime, C prime, D prime, which is also congruent to A double prime, B double prime, C double prime, D double prime. All right. And then let's look at the definitions of a congruent figure, which I've kind of already talked about. But congruent figures have the same shape, and the same size. So what we know is that if all angles and sides are congruent, then the figures are congruent. And here's one way that we show that mathematically. If you look at these 2 triangles, ABC and DEF, there's a couple things I want to point out. First of all, I want to point out the sides. So this side that I just highlighted in yellow corresponds to the side in DEF that I highlighted in yellow. So we would say that AB and DE are congruent sides. They're the same sides. AC would match up with DF, and then you'll see that BC matches up with EF. So that right there proves that all the sides are congruent. And then the angles, the way we show angles are with the one angle measure here. If you look at angle B, actually might want to not have so much yellow here, but if we just look at angle B right there, that's going to be the same as angle E. So B and E are congruent angles. And then if you look at D and A, they have kind of the double curve there. That shows that they are congruent. And then C and F are also congruent. All right, so what I'm going to do in example 1 is I'm going to look at these 2 triangles. And what I'm going to do is show what sides are congruent and what angles are congruent, just based on the markings that you see on the triangles. So if I look at the triangle ABC, I can say that side AB, which has the 3 markings, is congruent to side EF. And then BC, with the 2 markings, is congruent to FG. And then AC, with the 3, with the 1 marking, is congruent to the other triangles, EG, with the 1 marking. So that shows that all 3 sides are congruent. And then when I'm looking at the angles, I'll highlight it this time. You can see that angle B is congruent to F, angle A is congruent to E, and then angle C is congruent to Z. And the way that I would write that mathematically is the way I write angles is the little angle sign. So angle A is going to be congruent to angle E. Angle B is congruent to angle F, and then angle C is congruent to angle G. And that proves that if sides and angles are congruent, then I would say that I could say in the end that these two triangles are congruent. So I could finish this off by saying triangle ABC is congruent to triangle DEF. All right, got a little bit more here. So this is kind of a longer lesson, but I don't think it's too tough a material. So I want to list the corresponding sides and angles here. So again, this just takes a little bit of time, but if I'm looking at sides, I'm looking for the markings on the sides of the triangles. So I would say that BC is congruent to EF. AB is congruent to DE. And then AC is congruent to DF. And then as far as the angles, I'm looking for angle markings, and I have angle A is congruent to angle D. And you'll notice the congruent symbol I'm doing is just an equal sign with like a little squiggly line over top of it. That's the symbol for congruence in math. And then angle B would be congruent to angle E. And finally, angle C is congruent to angle F. And the only thing I'll say is both of these problems that I've just done, the triangles are all facing the same way and looking alike. I know it gets a little tricky when they start moving triangles around and the sides are not looking like the other side. So you really have to just pay attention to the markings, and that will help you determine which sides and angles are congruent. Okay, moving on. This is saying that these figures are congruent. So this looks like it's a trapezoid. ABCD is congruent to JKLM. And if they're congruent, it's saying that the sides are the same length. And so what I notice here is I notice that AD would correspond. So side AD is congruent to side JM. And if AD has a length of 10, then JM is also going to have a length of 10. So when it asks me for the length of JM, I'm looking for these two sides right here. And if they are congruent, then they would be the same length. So when it asks for what's the length of JM, I would just say 10. And then if it's asking for the perimeter, and if the perimeter of these two, the perimeter will be the same as long as sides are the same. And I know that sides are the same because they're both congruent. So if I could just find the perimeter for A, B, C, D, and remember that perimeter is when you add up all the way around a figure. And in this case, I'm adding 10 plus 8 plus 6 plus 8. So that would be 18, 24, 32. So the perimeter of this trapezoid, ABCD, is 32. And what I know is that it has to be the same as the other trapezoid, JKLM, because they are congruent to each other, which means they have the same sides. And so if the perimeter of ABCD is 32, therefore the perimeter of JKLM would also have to be 32. All right, wrapping this up here, we've got one last one to do. Given the sequence of rigid motions, draw the new figure. So I'm going to first take DEF and I'm going to translate it. It looks like it says x minus 1, y minus 3. And that tells me that that would be 1 to the left and 3 down. So I will take each point and move it 1 left and then 3 down. So there's D prime. 1 left, 2, 3 down. There's F prime. And then there is E prime. And then here's my new figure. But then what I'm going to do is take that, and now I have to perform a second operation here where I'm going to reflect the figure over the y-axis. I could do that by labeling points like this and reflecting it and doing the rule of reflection, which would be negative xy, but I also think I can just do it by sight. And if I can see the 3 points here, now I'm going to first reflect F, so it's 1 to the right, and I'm just going to move it 1 to the left. That would be F double prime. And then I'll reflect E, which is 4 to the right. So I would then move that 4 to the left. That's E double prime. Now I want you to notice something about D. If you see D, it's right on the y-axis. So when you're asked to reflect it across the y-axis, if it's on the axis, it just stays there. So that actually is a point that's going to just stay. And then I have my new triangle here, and they should be mirror images of each other, and that would be my final answer. So long lesson, but I think it's a lot of the stuff that we've done in the past. I'm just adding a little bit of new terminology with it.